Morning, everybody. Hope you had a good weekend. Looks like we're in this for the long haul. Hopefully you guys have printed out your notes. Follow along with this. Keep asking questions. I know that's the only way I can really help you guys. If you guys send me some emails and stuff on questions you have, so keep doing that. We're doing a great job. Hopefully I get back to seeing you guys again. But let's take a look at what we got today. Be dealing with independent and dependent events. So if we look at the first situation, they talk about Georgia license plates. You got 3 letters followed by 4 digits. So you got 26 times 26 times 26 for our letters, and then 4 spots for numbers. So when you look at this is why we don't run out of license plates. You have a total of 175,760,000 different possibilities for license plates. That's not even counting the specialized ones. The second situation they give us is if I were to choose one of you guys to be the president out of 16 people. We start off with 16. Well, you can't be president and vice president at the same time. So now I only have 15 people to choose to be my vice president. Now I want to go ahead and select my treasurer. All right, well, now I've chosen 2 of those original 16 to fill president and vice president. That only leaves me 14 people left, which gives me a total of 33,360 different ways to choose those 3 positions. The difference between these guys here is I can repeat the same letters. We've all seen license plates with 2 of the same letters on it. Here I cannot repeat. And that is going to be the difference that we talk about today when we look at these things. This is the fundamental counting principle, and we just basically multiply to get the number of outcomes for each event. So if you look down at the bottom, we've got our hearts and our kings that we talked about last week. We know that to get the king of hearts, there's only 1 of those, so I have a 1 out of 52 chance. What we're going to look at today is what happens if I pull 2 cards from a deck, 3 cards from a deck, and what happens if I replace them or don't replace them. Events can be either independent or dependent. Independent and dependent. Our independent events, they've got some examples of those at the top of that page there. Flip a coin, then spin a spinner. Roll a die, then flip a coin. Flip a coin and then flip a coin again. If I flip a coin, the coin doesn't remember what I got the last time, so it can go ahead and flip and get heads again. It's independent. It's free to choose whatever it wants to do. It is not dependent on any previous example. So if we look at independent events, probability of A times probability of B is equal to the probability of A and B. Alright? So if I want to figure out what the probability of 2 events are that are independent, I'm just going to multiply those things. So if we look at this first example, Michael is rolling a 6-die cube. Alright, he wants to get a 4 and a 3. So it's the probability of 4 times the probability of 3. So I got a 1 out of 6 chance, another 1 out of 6 chance. Gives a total of 1 out of 36. Second example, probability of odd. Probability of a number that is less than 5. Alright, we got a 3 out of 6 chance, followed up by 4 options that are less than 5, gets us 12 out of 36. So all we're doing on the independent events is just multiplying the 2 events. As we know, I can go ahead and roll a 4. Alright, the die doesn't remember what it rolled. I'm free to roll anything I want again. Last one, I've got probability of number greater than 4, probability of even. So I've got 2 numbers that are greater than 4. I've got 3 even numbers on the die. Gives me 6 out of 36. So it's just straight multiplication on the independent events. If I know 2 events are independent, this is our formula we're going to use to find out the and. I just multiply, like we said, the 2 things together. So if you look at that next example, they're not talking about die anymore. They just give us a couple decimals. Probability of A, 0.2. Probability of B, 0.4. If I multiply those 2 things together, that is going to give me the probability of A and B. So look at our next example, 28 names. Good old-fashioned teacher pulling a name out, just like I do with you guys. 16 girls, 12 boys. Chances of us getting a girl. Just straightforward, probability desired over total, 16 out of 28. What's the chance of me getting 2 girls in a row? If I put the names back in. Well, with 16 out of 28 the first go around, I still have 28 names in there. There's still 16 girls. So it's another 16 out of 28. So when I multiply those guys, and I simplify it down, I get 16 out of 49. Probability of getting a girl then a boy. 16 girls have 28. Put the name back in. I still have 28 people in there. 12 boys. And when I simplify, I get 12 out of 49. As long as I put the name back in there, we're fine. So if I do the next one, they're asking us, are the events independent? Well, as we've talked about, in order for them to be independent, they have to multiply and equal the and. So in this situation, I've got a probability of 0.3 times 0.2, and they want us to check and see if that equals 0.5. Well, we know 0.3 times 0.2 is not going to equal 0.5, so those things are not independent. So we're going to ask you to do tests on this. If those 2 multiply to equal the and, we're good. Probability of A and B is equal to the probability of A times the probability of B. Those events are independent. If it does not equal, those events are not independent. So now let's look at dependent events. So dependent events, basically they are things that the previous event impacts the future event. So I'm going to use my deck of cards that I used last week. I got my 52 cards in here. I got 2 diamonds. Well, what's the chance of me getting the 2 of diamonds? 1 out of 52. There's 2 of diamonds in there. 52 cards. Well, I pull. I don't get it. I don't put this card back in. There are now only 51 cards in here. So now what is my chance of getting the 2 of diamonds? Desired over total. That's the 1 card I want. There's now 51, so I'm now down to 1 out of 51. And it continues to decrease as we go along. So dependent events, previous events will impact the future probability. So if we look at the example 4, 32 people. Same situation. Teacher pulls a name out. What's the chance that you're the first one called? So the probability of being the first person, you got a 1 out of 32 chance. But I'm not putting the name back in. So now there's only 31 names. So the second person, what's the probability of you being the second person? You didn't get called on the first. But now there's only 31 people. Probability of the fourth, being the fourth person called. Well, the third is going to be 1 out of 30. So the fourth person is now down to 1 out of 29. And if I continue to go all the way and not put these names back in, sooner or later you will get called. If you notice, My numerator is staying the same. The denominator is going down by 1 each time. Remember, there's a third person in here. That's a 1 out of 30. All right. So if we look at this last example here, all right, standard deck of cards, 52 cards. All right. I'm going to draw 2. All right. I want to get what's the probability of ace and ace. All right, so 2 aces. All right, I got my deck of cards. 52 cards. All right, 4 aces. So I get probability of ace is 4 out of 52. All right. So I know there's an ace here on the bottom. I'm going to shuffle this thing up. Let's see if I can pull one. All right, let's see. What I get? You guys can't answer me because I can't hear you. 7 of diamonds. I did not get it. All right. I don't put that card back in. It is no longer in the deck. I am now down to 51 cards. All right. The probability of me getting an ace again. All right. If I pull the ace the first time, and let's find our ace. And let's look at this situation. Let's see. There's an ace. All right. So let's say I got lucky. All right. 52 cards. I pulled the ace. All right. The ace is now gone. There are now 51 cards, but now there are only 3 aces. So this is on my second draw. We're going to do the same thing. We're going to multiply these 2 numbers. Alright. When I go through and multiply those guys, simplify them out, I basically have a 1 out of 221 chance of getting ace then ace. Alright. So we're still multiplying, but notice my denominator is going down. Alright. If I happen to pull the card that I wanted, my numerator is going to go down. If I didn't get it, there still would have been 4 aces in there. Alright. I didn't get it actually, but we fixed it, so I did. Alright, so if we look at the second situation, alright, probability of getting a red card, then a black card. Alright, it's 26 red cards out of 52. Alright, so I pulled the red card. Alright, I got one. He's gone. Alright, I'm now down to 51 cards. Still 26 black cards. Alright, so I go through the chances of that. When I simplify this down, I get 13 out of 51. Still multiplying these 2 events. Last guy that we're going to look at, we got face card and then a 6. Alright, so face cards, there's 3 in each suit, 4 suits, so I have a total of 12 out of 52. Alright, I pulled the face card, got the king. Alright, so now I'm down to 51 cards. Alright, I'm looking for a 6. There's 4 6s in the deck. Multiply these guys out. If I simplify it down, I end up with a 4 out of 221 chance of getting it. Hopefully you guys get this. Hopefully you guys followed along. Put the notes down as we go. If you got any questions, shoot me an email. We will do problems on this on Tuesday. Once again, like I said, I hope I get to see you guys again. Take care. I hope everybody's feeling well, and I will talk to you later.